Real life. Hello, good evening, guys. I hope we just wait for a couple of minutes for other people to join in, and then we'll start.
Yep.
Hello, good evening, guys. Thank you so much for joining us. I guess we are good enough to start, and more people will join in as the workshop progresses. Today, we're going to talk about DeFi. Good evening, guys. Thank you so much for joining us. I guess we are good enough to start, and more people. Today, we have Deepanshu Tripathi, who is the CEO or CTO of Persistence, and he's been working in the DeFi space for some time now. Is also the co-founder of Cosmos India, and has been helping a lot of developers across the nation to learn about Cosmos and blockchain in general. And today we will be going through a very hot and interesting topic, that is DeFi. A lot of things is happening around DeFi, and it's one of the biggest use case of blockchain in present scenario. And something that's interesting is that how we can build powerful and scalable solutions in DeFi using Cosmos SDK is what we're going to discuss. So Persistence itself is an DeFi project which is trying to bring real world assets onto chain using NFTs, and those NFTs could be used to borrow stable coins, which is crypto, in exchange of these real world assets. So that's what use case we are working. We'll definitely discuss that as well in this workshop. So over to you, Deepanshu, and have a great time, guys.
Yep. Thank you, Abdesh. Thank you for that introduction. So yeah, hi guys. I'm Deepanshu, and today we'll be going through the workshop on how to build DeFi application. In general, to structure this particular workshop, we'll be starting off with DeFi basic definition. Uh, the term DeFi has recently become super popular, and there are a lot of products that are going around in the name of DeFi, which earlier were not named as DeFi. So we'll get into the details of what are the properties and characteristics application has to adhere by to be called a DeFi product as is. So we're going to go through the specification and discuss a bit about different DeFi products that are present out there right now and what all can be built. Looking at the current project set and also from the project set that are present in the current centralized finance domain that can be shifted now to decentralized finance with the tool set that we are going to present. So we're going to spend around 5 minutes on that. Then we are going to set up our repositories. So this part we'll just spend a minute. You can pause the workshop and like set it up yourselves. I've already set up the repositories fresh on my system in this particular directory workshop. So it's a clean setup. So after that, we are going to get into the modules that we are going to be utilizing from the Cosmos ecosystem, the Cosmos SDK. So we'll just get into the basic modules, the three basic modules that you need to build your DeFi application. There are a lot more there are a lot more modules out there in the Cosmos SDK that we do not need to worry about. We just need to know about these three basic ones. Then we're going to get into the modules at Persistence SDK. So in Persistence SDK, we have built out a couple of modules that are very relevant to building out asset tokenization, exchange, and financing use cases. So we're going to set out and figure out like discuss three modules from Persistence SDK that you are going to be utilizing to build your DeFi applications. So all these modules are composable. You can put in these modules in a permutation combination of sorts and build your DeFi application without coding at all, zero code required. And you just like pick your modules, compose them together, and you can start sending transactions to it. That's it. But in certain cases, in certain scenarios, if your use case is a little bit more complex, if you do require uh, uh, special implementation for your particular application, we are going to get into a quick implementation of how to build one asset module for any special asset class that you might be planning to build. In the previous workshops with Cosmos India that we had in the last 3 days, we would have already discussed how to build applications from the scaffold project from Cosmos SDK directly. In this particular one, what I'm going to do is like make it a little different, and we'll quickly get into how to build it using the interfaces and structure that Persistence SDK exports. So we're going to spend only 30 minutes on this, and mostly we should be done with building our own module in 30 minutes. After that, we are gonna get into discussions about special implementation, special features that we could have done in this implementation, but we did not cover in the workshop. We'll give a brief overview about where to look for resources to build those special implementation. Finally, we are gonna get into the DeFi toolset that is already present in the Cosmos ecosystem. So of course, if you're building your DeFi application, you're not gonna build each and every last decentralized service required for your DeFi application. There are a lot of very good projects in Cosmos ecosystem that you can directly integrate to, that you can directly utilize for building your application. So we'll discuss those. I'll give you guys links for the GitHubs of these projects, and you can get in touch with these projects and see how you can integrate the services from these projects into your particular DeFi application. So yep, that's how we are gonna structure this. We'll aim to finish off this workshop in an hour, and just to go over again, 5 minutes for definition, 1 minute for setup, 10 minutes to discuss about the modules, 30 minutes for our coding of our module, and finally leftover time for the toolset, DeFi toolset in Cosmos ecosystem. So starting off, what is a DeFi application? A DeFi application in general is any financial application that is fully decentralized. There is no central authority controlling like issuance or uh, uh, collateralization or defining the rates, etc. Even if there are parameters that need to be defined for this application, it does not uh, depend on decision making from one centralized authority, but rather governance. So that basically is DeFi application. What what is possible to be built with DeFi applications. Any financial service that you see in the centralized world, from banking to lending, stock market, exchanges, asset tokenization, uh, creating very complex financial instruments, SPVs, etc. All of this can be done through DeFi. Of course, if you just try to mimic the centralized finance and add blockchain as a layer for logging or for storing the event audit trail, in that scenario, that application might not be a DeFi application. That will be a MIS, management information system, uh, application. For it to be decentralized, all of the aspects controlling the uh, operation of this particular application should be decentralized. So getting into the basic specifications that your application must have to be for it to be called a decentralized application. First of all, it should be a financial use case. Of course, as the name goes, the application should serve some financial use case. So, what are the basic financial use cases? It could be credit markets, it could be token exchanges, derivatives or synthetic assets as issuance. It could be an exchange. It could be asset management, ownership management of assets. It could be predictive markets or speculative markets, etc. So the current set of DeFi applications that we are like seeing in the current boom of DeFi are AMMs. Those are automatic market makers. These are applications which allow you to exchange one asset against the other without there being a need for you to define at what price do you want to exchange it at, or the other asset owner to define what price they are going to exchange their asset at. There is a simple algorithm. There is a very simple algorithm that takes in the total supply of these two assets and spews out a number, which is the exchange rate. So those are automatic market makers, and those are very useful in scenarios where like the processing gas fees and the compute is very limited, like in cases of Ethereum. uh, then other DeFi application being lending, stablecoin lending. So in these applications, you take a couple of crypto assets and uh, collateralize them, and in their lieu you give out stable coins. Now you can utilize this stable coin for whatever your application or usage might be, and when you return back these stable coins, you have to pay certain interest and you get back your crypto assets back. So kind of like MakerDAO. Thirdly, there are exchanges, DEXs, for example, Binance DEX, which allow you to, without a central authority, exchange your assets based on a maker taker or central order book model. So yeah, these are the basic DeFi applications that can be built. There are, of course, a plethora. There are even financial applications that have not even been invented, and yeah, the possibilities are limitless. In this workshop, we might not be discussing about any exact financial use case to be solved, but rather we'll be discussing the tool set that one might require to build such applications. The second requirement for your application to be called DeFi is it should be permissionless. As is, there should not be one central authority. There should not be one kill switch. There should not be one set of people, permission people that control the parameters. For example, the interest rates or collateralization ratio, or the number of days an asset should be collateralized before you could withdraw it back, etc. It should totally be dependent on either the algorithm. It should be mathematically determined, all these numbers, or it should be determined by a governance mechanism, which we'll discuss later. The third requirement is it should be pseudonymous, which means there should be no KYC required. There should be no requirement for you to expose your identity, even without such scenarios, uh, you should be able to participate in these applications. Uh, Third is it should be non-custodial. So non-custodial, as in there should not be one single third party that take custody of your assets and issues your tokens in lieu, for example, e-wallets, etc. And third, and fifth and fourth, final one is there should be a decentralized governance. Now there are some scenarios, there are some uh, instances that might exist in the real world that you cannot codify in your a DeFi application code, that you have to depend on external actors to tell your application to change, for example, certain parameters around uh, tokenization, a collateralization ratio, or the interest rates, etc. So these parameters should be changed through a governance process by the holders of some skin in the game. Generally, it's a governance token, and these people vote to change these parameters. And instead of there being a centralized set of people to control these parameters. So, considering all of this, the one of the few things that we need to consider is a no super admin god mode etc. can exist. B, you have to enable all the parameters you have. You have to make sure that they go through. There is a governance mechanism to modify these parameters. Yep. So these are the basic like requirements that one has to like build into the DeFi application. And yep, going into the next topic, that is repo setup. So we're going to set up 3 repositories, the Cosmos SDK. We're going to be setting up Persistence SDK, and we're going to be setting up an example application called Asset Mantle. So the setup procedure is on your screen. It assumes zero information, except for, of course, Golang is installed if you want to run it later on. These are the like steps. Please follow it. And we have already set it up for this workshop, so we are going to skip over to the next heading, which is the Cosmos SDK modules that we are going to be looking at for building our application. So there are majorly 3 uh, the modules that you need to know about to build these applications: the bank, auth, and params module. So going through the code structure right now. If you look at Cosmos SDK, if you go inside the X folder in your Cosmos SDK repository that you just checked out, we just to like point out, we are checking out the repository at release stack 39.0. That's the long-term support version. So, and it does not have protobuf yet. It depends on Amino. It uses Amino for JSON encoding, decoding. So that's the version that we'll be demoing and utilizing also in our workshop. So as you can see, there are a bunch of modules here. We're not going to look at all of these. We're just going to be concentrating on auth, bank, and the params module. So looking at the auth module is basically the module that takes care of all of the activities relating to like a transfer, issuance of token, and like fees, parameters, etc. So the basic things that you need to like look at before you start utilizing this module in your application is you need to look at all the transactions that this particular module offers you, and all the parameters that are present in this module that may be modified through governance. So if you go through the CLI, that should give you the basic idea around how this particular module works. So this module basically exposes 3 major utilities, which is the transaction generation, transaction signing, transaction broadcast utilities. So yeah, this is the overall big transaction command, and we have your encode, decode commands, and we have the broadcast TX command. So, yep, like any module that you're going to be utilizing will have to depend on this particular module for the signing and the encode, decode, broadcast operations. Going into the bank module is what maintains the wallet. It's what maintains your account. So this is where you have the send, receive transactions, etc. So if you go inside client, you'll see the transaction send tx command, which is to send tokens. Easy part, right? In terms of params, if you look at the auth module in bank has is send enabled param, and yep. Moving on to the params module. This is the module which basically takes in your transaction for you to change parameters for other modules. So this is the only transaction in this particular module is submit submit proposal for param chain. So, yep, these are the three modules that one needs to be aware of in order to make their basic application. The basic application allowing for you to be able to send broadcast transaction, assign transaction, send tokens, and be able to change parameters. Getting into the modules at the persistent SDK level that you might require, we have the asset splits and orders module. So looking at the assets module basically allows you to tokenize any kind of asset that you might have in mind. So this is the basic structure of how asset looks like. An asset has one identification. Another properties that an asset might have, it's variant. You can have a bunch of immutables and mutables for a particular asset. Immutables is what determines the identity of the asset, as in the hash of the immutable gives you a part of the ID. And mutables are like your asset over a period of time may dynamically change its content. So for that, there are the mutable characteristics. The ID for the asset, we have a composite ID. The ID looks like this. It has a classification and hash. Classification basically determines what are the set of immutables and mutables your asset can have. So the main transactions that you need to be aware of in assets is mint, which is going to create your asset. Before that, we need to go into define. Define is what will define the structure of your asset, a classification of asset. Mint will mint asset of one classification. Burn will burn it off, and mutate can change the mutables in your asset. So that's asset. Going into the orders module. So orders module is what basically allows you to exchange your one variety of asset for any other variety of assets. So if you look at the structure of an order is basically the same. It takes ID, immutable, mutables. Orders also has the take, like in the mutables or immutables, you can have the maker ownable ID, which is the asset ID that the maker is offering for exchange. The taker ownable ID, the asset ID that the maker wants to exchange their asset for, and the maker ID, the ID of the person who is exchanging it. So you can like put in the split, the number of or the parts of asset that you want to exchange, and this particular module will allow you to like exchange any kind of asset again, any other kind. The transactions that you can have here is you can define a kind of order. Again, like assets, you can determine or define more complex kind of orders which have a set of extra properties. For example, there could be a contract for example, a written contract or a PDF contract that is stored on IPFS or on centralized storage that you can add on top of your orders, or you can have other like uh, real world parameters that you want to put inside orders that can go inside here. So you can define an order, you can make and take. Make is when you put out an order, put out an asset to be sold. Take is when you look at that asset and take it, and cancel is when you want to cancel it. So you might ask that, what are the different kinds of asset? Like, can I exchange one variety of coins for uh, NFTs? So that's possible, and that happens to the splits module. Splits is basically what manages the fractional ownership of the assets. Plus, what you can also do with the splits module is you can wrap your tokens. You can wrap your coins in either into splits. So the wrap and unwrap transaction will allow you to convert your tokens into uh, wrapped version of tokens that you can exchange against other asset on orders. And send is basically which allows you to send the fractional ownership of an asset or tokens to other people's wallet. So these are the basic modules from Persistence SDK that you might utilize for building your DeFi application. Now jumping into the most interesting part, that is how to build your own module. So starting off, like, we'll follow this whole uh, procedure set. We can Everyone can have their own like order of implementation, but for this particular workshop, we'll follow this but order of execution. So first, we'll define the directory structure for our module. So for this workshop, let's call our asset as a DeFi asset. It could be a complex asset class that you want to implement. We're going to be doing it in the same Persistent SDK project. You can do it, you can implement it anywhere else you like. It's not necessary. I just don't want to go through the setup process of like the directory structure setup process for another project right now, since we are restricted to 30 minutes. So, yep, starting off, naming the module name, we're going to call it DeFi Assets. Okay, looks like I've already defined DeFi Assets. We'll delete it. DeFi Assets. Now, the DeFi Assets will have an internal directory. This will have all the packages that we're not going to export outwards. Try to limit the surface of each module to as minimal as possible. All the packages that will go out can be utilized by other modules. We are going to put in auxiliary. And we do a prototype of this module. We will make a prototype of this module. So, yep. So to build this particular module, we need a few things. There's an interface defined in the Persistence SDK called the module interface. It's a helper interface. It takes a bunch of inputs and it gives you out a prototype for a module. So we're going to be utilizing that just to skip over all the boilerplate code we might have to go through. Prototype. New module. Now our new module requires a bunch of stuff. Requires name, param space, query route, transaction route, a mapper, genesis state, parameters, auxiliaries, queries, and transactions. So that's all what we're going to be defining now. So let's quickly go and define auxiliaries. Going to be defining prototype for auxiliaries based on new auxiliaries. Now, this new auxiliaries takes a bunch of auxiliary, uh, but like we'll get into that later. We right now just define all the prototypes. So we've got our auxiliaries. Next, we go and define transactions. Transactions also, we just define the prototype. We're not going to define the transactions right now. Transactions also takes a bunch of transaction implementations. And then we have queries. We're going to define queries. For queries also, we'll define a base, a prototype. So yeah, now we are ready with our auxiliaries, queries, and transactions. These are the basic logical units of any module. At the heart of a module is in MVC module, MVC architecture we'll call model. So that we call mapper in here. So we are next going to define the mapper. The mapper should have a base like entity that it is mapping. So for our case, since we are like making a module for DeFi assets, our base entity would be DeFi asset. So we're going to define a DeFi asset. DeFi asset struct. And of course, since it's an asset, we might want to make it implement interface, NFT interface. That NFT interface is too basic. So what we're going to do is we're going to be using a little more advanced interface called the inter-NFT interface, which also enables interchain transfer of NFT. So we are going to make it implement inter-NFT interface. So these are all the methods that we need to implement for us to be able to implement inter-NFT interface. Then we go on and create a quick constructor for this, make it exportable. We're not gonna be adding any members right now to this. We'll go ahead and add these as required. Next, we need to add a collect ID for this particular asset. So let's go ahead and define a DeFi asset ID. DeFi asset ID struct. So in this case, we are gonna be going ahead and make it implement. I'll do a quick constructor and make it implemented interface, the base ID interface. For that, we need to implement all these methods. We are going to skip this also right now. So yeah, get ID is coming from two different. So we got our base entity and its identifier. Next, we'll define a entity manager, and as we call it in MVC. In this case, we'll call it a collection. Yeah, so DeFi assets. Let's name this collection DeFi assets as a multiple DeFi asset. Type DeFi assets. Struct. Let's bring in a quick, make it implement the inter NFTs interface, which is a collector phase for inter NFTs. And yeah, and next we go ahead and define a quick constructor for this. So there's the constructor, let's put it at the end, make it exportable. Yeah, we've got a constructor ready, we have got our entity ready, we've got our ID ready. Next, let's define a few constants. So these any string, any like fixed parameters that will utilize for uh, identifying this particular module, we're going to be putting in constants. So for in constants, let's go ahead and define the first we'll define the KV store prefix. So in Tendermint, like we have a byte store, DB byte store, and we throw in all the like entities into that byte store, and the way to identify these is through a like a module level prefix. So let's define that first. Store prefix. This is gonna be of type array of byte, and we'll take 0, 0x. Let's say 22. Then let's go ahead and give it a module name. Module name. DeFi assets, and yeah, I guess that's it. Those are all the constants we might require. Then we define a basic mapper prototype. Prototype equal to base mapper. To give the module name. Then we've got to give the parameters. Yeah. So one more thing that we need to define here are the parameters for this module. So as I was discussing earlier, all the modules the parameters should be like changeable through only governance. There should not be one centralized authority that should determine the parameters for your DeFi application. So let's define the parameters for this application. For now, we're not going to be again doing any special implementation for the parameter. We'll directly go and define a prototype with empty parameters. Of new parameters. Parameters are like every other base, like new prototype implement method. It takes a bunch of parameters to give you a parameter prototype. So going ahead and plugging that into our parameters. Okay, I made a typo. I think we're going to stick to it. PRA. That is the prototype. Now we've got the prototype, and next we've got to give a key generator. So what's a key generator? It basically creates the bytes for your key. Key generator. So as I was mentioning earlier, in Tendermint, all the entities go inside a byte store. So the key for this byte store should be defined by our project. So we take an ID, which is the DeFi asset ID, types the ID, and we try returning a bunch of array of bytes that represent our uh, key store key. So this will look like, it should have the prefix. So we'll get the prefix, our store prefix, AV, yeah, AV store prefix, and we take the DeFi asset ID, DeFi asset ID, and get the bytes of it. Bytes is a method that all IDs have to define. Variadic, make it variadic. All right, we got the key generator here. Now we plug that key generator here. Next, we have got to give a mappable prototype. So in our scenario, our DeFi asset is the mappable prototype. We are gonna give new DeFi asset as a prototype for our scenario. New DeFi asset, so asset prototype. Then we've got to give a register codec. So quickly defining our codec here. In in this SDK, we utilize Amino for encoding, decoding JSONs. So gonna be doing a register codec. So define a function to register codec. Codec, it should take codec. So yeah, that's one mistake that we can make here. There are two codecs right now that we can utilize. This target update will allow you to utilize, it will be utilizing protobuf, Google protobuf. But for now, version 39, we are going to be using the older Cosmos SDK codec, which is basically Amino codec. So, let's see. Yeah, I think for this part, we can directly take reference from some of the module here. Yeah, so we do a register codec of register concrete. We got register concrete. All the structures we have defined, we've got to make codecs for them. So the structures we have the DeFi asset. We've got DeFi assets, and we've got DeFi asset ID. Name them accordingly. And we've got to have a module route. So right now what we're going to do is we are going to give the module name as the route for now. Module name. So this string basically becomes the identifier for my struct when it's marshaled to a JSON format. Okay, so yep, I've got a codec, register codec method ready. So give your register codec, and what's left now? Okay, need to define a prototype for our mappable new assets. Not connect. Got it. So this method should return types dot mappable. It's mappable. It's return our DeFi asset. So plug this in, and yep, here's our prototype ready for mapper. So now we have got our mapper sorted, we have got our parameters sorted, queries, transactions, and auxiliaries are in undefined state. One last thing that we need to define, boilerplate code that we need to define is the genesis state. So let's go and define a prototype for a genesis state. Genesis state. Make it implement the Genesis interface. So Genesis interface require me to implement all of these methods, and we do a quick constructor for this. Make the constructor exportable. So yeah, that's my Genesis state prototype. So yeah, let's see if we have everything to create a new module now. So a module requires a module name. We've got that in mapper package. Then we have got to supply the default param space. That's a string to identify your parameter space or parameters that we just defined. So we are gonna like a little hacky method and define this as our param space identifier string. And next we have got to supply the query route. So again, employing our module name plus adding query as the identifier for our query route. When we will have the transaction route module name. So this transaction route will be what will show up as the route in your REST endpoints also, that will be auto-generated in the next step. Next, we're going to supply the mapper. We've got the mapper prototype ready. Then Genesis state. We've got the Genesis new state. We're going to use new state as a prototype. We've got parameters next. Okay. Let's name this package. So it's now mappers or prototype. Got the parameters prototype. And we have to put in the auxiliaries, queries, and the transactions. So pick those up. Auxiliary prototype. The queries prototype. And the transactions prototype. Yep. So that's a module. That's it. It's ready. We can start utilizing this module inside our application. Let's do a quick sanity check. See if there are any errors in our project. Yep, looks like there are a few warnings, unused parameter warnings, but there are no errors. So yep, looks like our module is ready. So let's go on to the next step. We've defined our directory structure, we've defined our mappable, we have defined our ID, defined our collections, the DeFi assets, we have defined parameters, we have defined the constants, we have defined our codec, and we've defined the mapper prototype. We've defined our Genesis state, we've defined the auxiliaries, we've defined our transaction queries prototype, we've defined our module prototype. Next, we're going to create an application. Here also, we have got a base application ready. We are just going to add this new module inside that particular application. So let's check out our base application. So a schema, we've got applications, and there's a base implementation of application that we have got implemented already. So basically what this does is it defines a base structure for an application, implements the application interface, and gives you a prototype, a creator for your application. So this method takes in like the setup parameters for your application and gives you a new application that you can utilize to run directly through run directly and move forward. So for this particular application to add our module to the application, we just need to go ahead and plug it in at a few places. We have got to add the key store, the KB store that we defined, and you got to add the KB store into our application. So what we're going to do is copy paste assets, use DeFi assets dot prototype dot name as the name of a key, and we're going to use DeFi assets dot prototype dot get KB store method to get the KB store method that gets auto generated. Next, we initialize our module. So for each module, you can import other modules, auxiliaries of other modules to do more complex operations that we're going to discuss in the next section. But for now, our initialization will be very simple. We don't require any of these special auxiliaries from other modules. We directly do a simple initialization of our module. So DeFi assets.prototype.initialize, and we give the param space, params keeper.subspace, and we give it a name. DeFi assets dot get default param space. The default param space we defined in the prototype definition, if you guys remember. Yep. So that's our module initialized. Next, we go towards if you want to enable WASM smart contracts, if we want to enable this module to be able to interact with WASM also, we can add the encoders. We have got encoders for, we need to define special encoders that take JSON message and convert into messages that your module could understand. In our boilerplate code, it's already covered. So we can, if you want to enable WASM smart contracts for your module, you can directly go and add it to this list, and your module will be able to interact with WASM. Next, we add a module manager. So our module prototype directly implements module manager, so we can just supply the prototype and our module manager will take care of it. Then we set in the Genesis order. For our case, it does not matter, so we're going to add it right after assets. And then we got to define a new simulator. Since we don't have any parameters here, it does not make sense to add simulator, but still, just for future scenario where we might add more parameters, we can add, and simulator for the parameters, we can add our module for the new simulation manager. This new simulation manager is basically gonna utilize the methods that you have defined in your parameters to create random parameters and test your modules. Yeah, that's it. Our module is added to our application and we are ready to go. We are ready to go with our application. So now, let's look at the list. Where are we at the list with the list at? We have added the module to our application. Next, we need to run the application. For us to run the application at this point, it might be a little difficult because we have skipped over implementing a lot of the methods that the interfaces require us to define, and the auto-generated methods would panic if we go ahead and try to run the application. But still, I'm going to show you how to run the application anyway. So in all the implementation, we have got panics. So if we try to run this application, and this method is called we'll get a panic. So for that scenario, uh, when in the future scenario, whenever you have implemented these methods, you can go ahead and continue with the next steps. So the next steps will be for our scenario. We have got this project called Asset Manager. You can check it out in the repo setup. We have listed how to set up this particular repository. So if you look at the application, it defines the prototype, it defines the basic modules, and it creates an application from the parameters. uh, a base implement it creates a new application from the base application. So since we have put in our module in the base implementation of application, it's going to get imported here. So here we got to make sure that the SDK version or the version of the uh, project where your module is sitting is updated, and then of course you can go ahead and start setting up your project. So for the setup, I've created a small script. So this script will basically like set up the Genesis state for your like different modules that you have imported, and uh, set up different accounts and like tokens that would be required for each of these addresses of the modules to run. So first of all, you do a make all. Make all basically is a recipe which is listed here, which basically builds the project. And we then remove the old like state of the application. We create these new directories just to be sure. Then we've got to initialize the key. We do a recovery of we put a recovery of this key so that the like default seed remain the same. So throughout our application, we have got one. Throughout our test cases, we have got one Genesis uh, uh, address to take care of. Then we have got a Genesis state account, give it a few stake, and we have got uh, create GNTX, then collect GNTX. So this is our script. We are gonna go ahead and run this script right now to set up our application. So it's in the folder in the asset manager project. It's in the folder .scripts. So yeah, we run this particular script, and yeah, looks like we have created our key. This is our Genesis state key, and this is the Genesis state that got created. Looks like there was an instance already running, so that panicked. No problem. We're gonna set it up again. Yep. Yeah. So setup has run successfully. Next, we try to start our chain. Just do a startup.sh. So yeah, startup.sh is going to take care of all the like commands you need to run to start your application. Just to guide you through what basically does. Basically does a application name space start. It just runs that command and inserts all the logs into a file, and then it's the command that you require to run up that particular node. Okay, looks like there's a application already running uh, on our port, so we're gonna quickly kill it. Okay, so Yep. Let's try running our application now. Okay, looks like something else is running also. Let's do 6657. Let's check if yeah, something running there also. Still that process too. Just to be sure, let's see if 1317 has rest. No. Now let's try. Only encourage you to go through the bunch of modules present at Cosmos SDK already present, and the modules present in Persistence SDK, the modules present in uh, all the other Cosmos ecosystem projects, and see if the module, if there is already a module present which fulfills your requirements already instead of defining a new one. Even if you need to define a new one, as you just saw, it's very easy to define a new application. So, yep, let's go on into the more advanced discussion. So, how do you define a transaction logic? So, in our implementation, we had skipped over defining transactions, auxiliaries, and queries. But let's now get into how do you define it. So, if you take the reference of, let's say, assets here, if you go to any of the transactions, let's look at the mint transaction. So for the mint transaction, if you want to define a new transaction, first of all, you define the constants, the name of the transaction, route of the transaction, the short and long usage of the transaction. Then you can define the request. So this request is what comes through your external client. So this could be REST, it could be CLI. So you need to keep this request simple. Do not try to put in complex structures that you are defining your project, but rather take in simple data types like string. So this is what a request will look like. Again, I've defined a simple interface that you guys could follow. That is the transaction request that you need to implement. So you need to define these methods from transaction request, which will be get base request from CLI, from JSON, make message and request. Then go ahead and define your method. So this is what will get created from your request, and this is what your SDK will understand. This is what your module will understand. This could have more complex data types that you have yourself defined. For example, in my case, I've defined ID. There is this Cosmos SDK account address type. We have meta properties. So again, this message should implement SDK Cosmos SDK's interface called message. That interface will require to implement routes type, validate, basic, get signatures, bytes, and get signatures. After you define these two, then you can directly jump in and define your keeper. So keeper is basically where you like take in the message and like put in the application logic, the base core application logic. This is the only area that you need to put any effort in. Uh, Other than this, all the other files are just boilerplate codes. So here you take your message, you have got your mapper, your transaction. You need to define the transaction keeper again and make it implement the transaction keeper interface. If you've got the mapper basically defines your basic CRUD operations. So create, read, update, delete for your module entity, iterate, and then there are extra methods also like get KB store key decoder, and register coder that you might not utilize here, but are required for application initialization. So utilizing these methods and on top auxiliaries from keeper auxiliaries from other modules, you can define as complex application logic as you want, and that will constitute a transaction. So again, transaction prototype, you can define like paste a new transaction and put in all these details, and you'll have a new transaction at your hand. After you define the transaction, make sure that you put it like in the prototype definition, we had left the transactions empty. Here, you just add your transaction here, like burn mint, etc. It's a variadic parameter set, so you can add as many or none also. Similarly, you can define queries. Queries also follow a very similar directory structure and prototype definition. And and then auxiliaries. Auxiliaries are basically uh, application logic that you want to export to outside the module. Everything else except auxiliary stays inside internal package. Everything else goes outside. You want to reduce the surface of your application to as minimal a module as minimal as possible, so that if someone is creating an application using your module, you know that these are the basic KPIs that this particular application is going to stick to. For example, someone is using assets module from Persistence SDK or identities module from Persistence SDK, then we know that that particular application is at least following the protocol that the Persistence SDK has set for defining identities and assets. All right. So going into using other modules, as I just like mentioned, when you are initializing any transactions keeper, you can demand an extra set of auxiliaries, external auxiliaries, and in your keeper struct, you can add these auxiliaries like so. You put the initialization in the initialization method, and after that, you can, for example, in this case, we have got this scrub auxiliary, which basically removes the metadata from your assets. So here we've got the transaction keeper dot scrub auxiliary dot get keeper dot help method. It takes a context, it takes a request, so you can get the scrub's new request, add the request, and that's it. Like that, it will return you back either an error or a successful response. So that's how you import and utilize other modules keepers. Then we have transactions over IBC. Now, with the Stargate update, of course, we are going to be getting capabilities of being able to interact with other blockchains. And for now, the Cosmos SDK, it allows you to transfer coins or tokens, the bank module transaction, the Senko transactions over different chains. So basically, you can send tokens from wallet in one chain to a wallet in another chain. Similarly, if we are implementing specialized modules, for example, in Persistence SDK's case, we have got identities and asset modules. So we define special transactions, IBC implementations that will allow us to send assets or identities over to other unutilized in other chains. So that's something that's coming up. That's something that's still in development. But that's the specifications on it. It's still under work. We're still working on it, and yeah, soon after the Stargate update, we are going to be seeing many of these modules. For example, the bank module from Cosmos SDK, assets and identities module from Persistence SDK, that you will be able to do transactions across chains without having to worry about setting up connections or setting up any extra code around it. So yeah, that's all the discussions. Now going into, I think we have ran 10 minutes over our time, but going into the final topic, which is the DeFi toolset. When you're building your application, DeFi application, you might have to depend on external services. For example, Oracle Network. What an Oracle Network can tell you about is if there's some parameter or data that exists out there in the normal centralized world, and you want to trustlessly put that particular data over to your chain, you're going to be utilizing an Oracle network. So in Cosmos ecosystem, we've got a kick-ass project called the Band Chain Protocol. The band protocol, the band chain project is what you need to check out. And when target update happens, we'll be able to like import uh, the Oracle data, the Oracle parameters from band chain over to any of the modules that you're building for your DeFi. Another great utility that you might want to utilize is AMM, automatic market makers. So ISO Foundation has built out a market maker uh, called Cosmic Bonding, so which is available at this particular link available here. So what this will allow you is to define a bond curve for exchanging two tokens that you might have defined in your project, and do automatic market making for it, allow you to exchange these tokens without you having to define the exchange rate. The AMM algorithm will define the exchange rate. Then we have got stable coins. Again, this is an excellent integration. If you want stable coins in your project, then the Terra project uh, has defined two stable coins right now, Korean won and Terra USD, which are pegged to Korean won and USD respectively. So if in a DeFi application there is a requirement for stable coins after Stargate, one will be able to like get these stable coins, buy stable coins from market, and be able to like send them over to your chain, and you can utilize it in your DeFi applications. For EVM smart contract, we've got the Ethereum project, which I guess yesterday or day before yesterday, we would already have had a workshop around. And for Wasm smart contract, we have Cosmos Wasm project, which is now in version 1, 0.1. And I guess this is another project that we had a workshop for in the last 2 days. So yeah, these are all the tool sets that we could have covered in an hour. Of course, there is a lot of depth one can get into when defining or discussing DeFi projects. But I guess, and I hope that this workshop was able to like help you get started with building complex DeFi projects in Cosmos ecosystem. Yeah. All right. Thank you, guys. That will be all from my side. Abhidej, if you would want to take over.
Yep. Thank you so much, Deepanshu, for such a comprehensive workshop on different getting starting with DeFi. And thank you everyone for joining today. I guess we have gone through a good journey of different tools that can be used to build applications in the HackAtom India hackathon. So please go out there and start building dApps, and any help you need. Of course, we are open on our Telegram channel. We are open at the Cosmos Discord channel, where you would have a lot of developers, and they will help you out. In case you require any further clarification regarding bounties or how the judging criteria would be, please refer our hackathon page on HackerEarth. And we would also like to thank HackerEarth team for helping us out with this HackAtom week that we have been organizing for last 1 week. And we hope to see a lot of good projects coming out of Indian ecosystem through these hackathons, and hope to see a DeFi ecosystem booming in India itself. Have a great day ahead, and happy hacking. See you guys soon. Bye bye. Take care.